In Learning Target 16, we're talking about tangent and cotangent. So we haven't really talked about those since we talked about the unit circle, but we're going to go back and we're actually graph those today. I have a fill in the blank at the top of your note sheet, but we're going to go back and do that in a second after we've actually looked at the tangent function. Okay? I'm going to set up the tangent function today like I did the very first time we graphed sine or cosine. I used the unit circle to figure it out, right? That's the first thing we're going to do today is we're going to look at it based on the unit circle so you know where the shape comes from and everything and you're not like, she just made up math magic. Okay? So, all I'm going to do is I'm going to look at all the radian measures, so like 0, pi over 6, pi over 4, pi over 3, etc., etc. And that's going to be my scale for my graph. I'm not going to write every single one down, but that's what I'm using. Now, if we're talking about tangent on the unit circle, and I will come right back to this, I promise. I'm talking about tangent on the unit circle. How do I find tangent if I'm looking at 0? Like, how do I find tangent? What would I do? Sine over cosine or y divided by x, right? Whichever way you remember it. Okay? So keep that in mind when we're doing this. We're always looking at the unit circle. We're looking at sine over cosine, or we're looking at y divided by x. Okay? So everyone knows where I'm getting these numbers from. So on the first one, back here at 0. Y is 0, x is 1. So what's 0 divided by 1? 0. 0 divided by 1 is 0, so there's a point at 0, 0. That's going to be important a little bit later. Okay, then we keep going, and we have 1/2 divided by the square root of 3 over 2. Since I'm graphing, I don't really care if it's the exact answer or not. I just want the decimal. And I get 0.577. So we'll say this is 1. So 0.577 is a little bit more than half, right? Then I would keep going. So at pi over 4, you have the square root of 2 over 2 divided by itself. So what's that? 1. So a point at pi over 4, 1. And then I have the square root of 3 over 2 divided by 1/2. No, that won't work. They get 1.73. So we can already tell that they aren't going to be confined like sine and cosine was always confined between 1 and -1. We started to change the amplitude. It had some boundaries. This one goes beyond that, so 1.73. So we'll say this is 2. Right? Then if we're at pi over 2, we have 1 divided by 0. What's 1 divided by 0? Undefined. So if it's undefined, that means we have an asymptote on our graph. There can't actually be a point there because it's undefined. So it's one of our boundaries. So far, there's not really a distinguishable pattern, right? So we're going to keep going so you can kind of see where the pattern comes in. Okay? So keep going on the unit circle. Now this time, I'm not going to have to divide everything on the calculator because I'm going to start repeating right, what the values are. They're just going to become negative and that kind of thing, right? So 2 pi over 3, we do the square root of 3 over 2 divided by -1/2. So we adjusted that, and that was 1.73, but now it'll be -1.73. So we'll make this -1 and -2. So -1.73. And then at 3 pi over 4, we have the square root of 2 divided by 2 over the negative square root of 2 divided by 2. So that's -1. That's down here. And then at 5 pi over 6, we have the same thing we had at pi over 6, just negative. So that was 0.577. But now I have -0.577. And then at pi, we have 0 divided by -1. That's just 0, right? And if we keep going around, this is where it starts repeating. Okay, if you keep going around, the next quadrant, the third quadrant, has the same values, right? We've looked at the unit circle a million times, except in the third quadrant, x and y are both negative. So when you divide them, you get a positive, right? So we get back to where we're at, 0.577, 1, 1.73 asymptote. If you go to the fourth quadrant, again, you have the same values in the unit circle, right? It's always the same coordinates, just different quadrants, so different signs. So the last quadrant, you have a positive and a negative, so we're back down here in the negatives. We start at negative 1.7, negative 1, negative 5.77, 0. Now it's important to remember there's a lot of, you could use any radian measure. So you could use any radian measure in between any of these little intervals, right, and we come up with the curve. So these are not straight lines because there's this boundary, right, these asymptotes. An asymptote tells you that a function is going to get closer and closer to that and never cross it, right? So if I'm going to draw on this curve, I'm going to do the one in the middle between the two asymptotes because that's one full curve here. It hugs the asymptote and then comes down and curves around through the center, and then it comes down and curves around back towards the asymptote. I'm sure there's a name for it, but I don't know what it is, so I just call it a squiggle. I know it's real technical. But so over here we had half of one of the squiggles, so we know that it would have continued on down here. Over here we had half of a squiggle, and we know it would continue on up there. But they're not straight lines. That's important to remember. So, going back up to the top of that note sheet then. It says, the period for tangent and the cotangent function is, the period will be how often it repeats. So between the two asymptotes is one full period. So what is one full period for tangent or cotangent? What's the distance between 3 pi over 2 and pi over 2? 2 pi over 2, which is pi. Right? It's half of what we're used to with sine and cosine. So the period for tangent and cotangent is just pi. So it repeats more often. So I continued that sentence, and I said, so we use pi over k when we're working with those functions. So all those things we know with the period so far for every other sine, cosine, cosecant, secant, we always did 2 pi over k. We have to use pi over k now because our period is shorter. Okay? And we'll get into that in some of the examples at the end. All right, so some important things we need to note here. Because when I did this for sine and cosine, we went through the whole entire unit circle, and then I said we're going to identify some key points that we can use so that we don't have to keep plotting all these random points all the time, right? We can do the same thing here, okay? We can still figure out the period and divide it into fourths, and there are 4 then key points, okay? We have the one at -1, with a point at 0, a point at 1, and then we have an asymptote. That's what you would have as the repeating pattern when you're graphing these. When we go into the ones later where we're actually doing shifts and things, that's what you have to remember. We have -1, and we have 0, 1, asymptote. And that's what's repeating each time. Okay? Also, when we're shifting everything, for sine and cosine, when we were shifting everything, we always talked about that first point. That first point is whatever was happening at the y-axis, right? So here for tangent, the first point is at the origin. So if we're going to shift tangent, we're actually shifting the middle of one of the squiggles. Does that make sense? Okay? So that's going to be important when we're shifting one of these later. Okay, and we'll come back to all that and do it all together. But those are there's key things to point out. Okay? Any questions so far about tangent? What it looks like, that the period is pi, where I got any of these numbers, why there's asymptotes, anything like that? We'll come back to it in a second where we graph one where there's some different things going on. Okay? Questions? All right. let's look at cotangent really fast. I won't spend as much time because we just did this whole thing with the unit circle, but I do want to do the similar setup. If tangent was sine over cosine of y over x, then what's cotangent? Right, x over y or cosine over sine, right? We don't have to graph all of these. If I was using the unit circle again, though, this would be what I was graphing, right? Now, cotangent is very similar. Okay, very similar. Still the period of pi. It's going to have a similar shape. Okay, it's just not the exact same thing. So I want to make sure we point out some other things. So I'm just going to look at the unit circle just for a second so you can see where I get this started, and I'll go from there. So if this time we were looking at cotangent, we were looking at 0. Cotangent would be 1 divided by 0 instead of 0 divided by 1, right? So 1 divided by 0 is undefined. So that means this time at the y-axis, we have an asymptote. Now tangent, if we were following that same pattern, right? Tangent would start down here, right? It would go up, yada yada, right? And we'd have another asymptote. But cotangent, though similar, is not the exact same. So do not think it has the same exact pattern. Okay, because it doesn't. So don't get caught up in that trap. So if you look at this point at pi over 6, instead of having 1/2 divided by the square root of 3 over 2, we get the square root of 3 over 2 divided by 1/2. So instead of that 0.577, we have the 1.73 first. So that means we start up here. At pi over 4, we would still have 1, because to divide something by itself, it's still 1. And we would go back to the 0.577. So what happens is the pattern is inverted. So it's like the opposite direction. The period's still pi. It's still a squiggle, just the opposite direction, right? And this time, if we're going to do a phase shift, what's happening at the y-axis? Well, there's an asymptote, right? So if we're going to graph cotangent and there's a phase shift, we want to shift the asymptote, okay? So for cotangent, you're always going to have the asymptote, and then it starts at a high point. So it starts at 1, then 0, then -1. That's the wrong one. I circled the wrong one. 1, 0, -1. Asymptote. So if I wanted to continue this, have the same pattern, questions about how I came up with cotangent? All right, then I've got 2 graphs on there where there's extra stuff happening. Vertical shifts, phase shifts, that kind of thing, right? Everything works in generally the same way, okay? So I will flip back to tangent and cotangent, the ones we've just done, so we can see how we're going to move things in a second, okay? So let's do these 2 together. I think it won't be that bad. The first one just says to graph tangent of theta plus pi over 4. So is there a vertical shift? No. If there was, it's not a big deal. You, instead of graphing the center point at 0, you graph it at whatever the midline is. It's no big deal. There's not going to be an amplitude on any of these. There could be. Again, there could be a vertical stretch, and that just means that it'll be lengthened out. But our book doesn't do that, so you don't have to worry about it. Because there's not going to be an amplitude on any of these. Okay? So then the next thing you look at is the period. The period is always going to be, again, pi over k for tangent and cotangent. So k in this case is 1. Whatever's in front of the theta still. So pi over 1 is just pi. We still divide the period by 4 to get what our scale is. Still the same. So pi divided by 4 is just pi over 4. So that's what I'm going to count by. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and I could keep going. I probably will in a second. I need to keep going. But any questions on where those numbers came from? All right. Then there's not, is there a phase shift? Yes, there's a phase shift. It's still C over K. So what is C? Negative pi over 4. Divided by K. K is still 1, so it's just negative pi over 4, right? So I need to make some marks over here because I have negative pi over 4. All right. We also know that we're going to be using those points at 1 and negative 1, so we can go ahead and draw in that if we would like. This is a tangent function. So I'm going to go back to the one we already graphed for a second. If we were going to start with the origin, right, that's the point we're going to shift. So our shift is negative pi over 4. So that point in the middle is what we're shifting. Is everyone with me? Okay. So I'm going to graph my first point right here. Does everyone understand why? Okay. Then when we're graphing this, the next point, again, we're skipping all those little incremental ones in between. So the next point is going to be the point at 1. All right, so at 0, 1, we're going to have a point. Right, it's middle, and then 1, and there's an asymptote, since we started in the middle of our squiggle. Okay? So at pi over 4, then there's an asymptote. And then we would do the whole entire pattern. So then we start at negative 1, the center, 1, and then at 5 pi over 4, there'd be another asymptote. Does that pattern make sense? Once you have an asymptote, you're just going negative, middle, positive, asymptote. Over and over again. Again, dividing the period by 4 ensures that we're going to hit those points. Okay, are we okay with that one? Yeah? Okay. On the second one, we have y equals cotangent of 2 theta minus 4. So this time, is there a vertical shift? Yes. Vertical shift of negative 4. So that means my midline isn't going to be at the horizontal x-axis. It's going to be at negative 4. Again, our book isn't going to change anything with the amplitude or anything like that. So instead of going from negative 1 to 0 to 1, we'll go from negative 5 to negative 4 to negative 3. Right, it's always just going to be plus or minus 1 for now. Okay, so we know there's a vertical shift. We already talked about how the fact there's not going to be any amplitude changes for now because our book's not going to do that to you, right? And so then what about the period of this function? Pi over 2, right? Pi over k, so pi over 2. So if we divide that by 4, that's like multiplying by the reciprocal of 1/4. So we get pi over 8 as our scale. So pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, etc., etc. Yes? there a phase shift? No, there's not a phase shift. So we can just start at the y-axis then. So going back to look at cotangent, on the y-axis at cotangent there's an asymptote. Since there's no phase shift, there's still going to be an asymptote on the y-axis. If there were a phase shift, you would shift the asymptote. Okay? So we have an asymptote right here. Let's say the phase shift was negative pi over 8. And I would just shift the asymptote over that one little interval. All right, for cotangent then, the pattern is maximum, midline, it's not really minimum, it's not really maximum, minimum, but the high point, middle, low point, asymptote. And then I keep saying high point, low point, that we know goes to infinity and negative infinity, right? So, -3, -4, -5, asymptote. -3, -4, -5, asymptote. Question. There's only 2 graphs in your homework assignment tonight, so don't freak out too much. All right, then the last part of learning target 16 is just writing an equation. Everything is the same while writing the equation, as it always has been, except for the period is not 2 pi over k, it's just pi over k. So we're writing a cotangent function, so we have 2 pi equals pi over k instead of 2 pi over k. So k is 1/2. Is everyone okay with that? So we know we have y equals cotangent of theta over 2, or you can write 1/2 theta, it doesn't matter. And then the phase shift stays the same, it's still c over k. So negative pi over 4 equals c over 1/2. So I cross multiply and I get negative pi over 2 equals 4c. Divide by 4, so c equals negative pi over 8. There's still a negative in the original equation, so we'd have negative pi over 8, so plus pi over 8. And since the vertical shift is 0, so we don't have to add anything else. So really the only thing that's changed is the period part. Everything else is pretty similar. And when you're graphing, the shape obviously has changed, but there's still a pattern to it. Question.